Crystal, you're going to have to do better if you're ever going to work your way up the promotion chain. All right, so make sure that everyone has 11 4 notes in front of you. Today we're going to relate the area and the circumference of a circle and be able to work back and forth between their formulas. So we want to start by making sure that we all remember the important formulas. So, not to put anybody on the spot this morning, but I'm going to. Zach, you are on top, sir. Do you remember the circumference formula? I gave you guys a little trick yesterday to remember it. What is crust before you bake it? Dough. So crust is equal to pi dough. Eminal, do you remember our area formula?
I know it. Okay.
I forgot.
You can pass it off if you don't.
No. What?
Luke, do you remember area? Starts with pi.
I know it's pi.
Class.
Radius to the second power.
Radius squared. Pi radius squared. Put those on your notes right now somewhere so you can refer back to them as we go through the lesson today. What? Have confidence. Let me get back with my notes pulled up here. You write those down.
I want pink.
Give me one, Bella. I don't know.
All right, so everyone have those written down. A little reminder on your paper. Circumference is pi times diameter, or crust equals pi dough, and area is pi r squared. I had a student, I think it was 2 years ago, they said they remembered area by thinking about like pixels, how something gets filled in by squares. Anything that you look at on a screen is actually all squares. There are no round objects on a screen. So pixels are square. The area of a screen, pixels are square. I don't know, it helped them remember it. So if that helps you. Yeah, pixels are square. Everything you see on a screen is square.
So even if you look up a circle, that's also square.
If you zoom way in on it, the line of the circle is made up of tiny little squares. Yep. All right, so does a greater distance around a shape always mean a greater area? So when we think about rectangles, can you think about different size rectangles that have the same area but different perimeters? So I want you guys to try on your paper right now. Try to draw rectangles with the same area but different perimeters. Or if you draw different rectangles, like with different areas, how do their distances around or their perimeters relate? It's like a really easy one is if I only go 1 tall and 2 wide, well, that have an area of 2. But if I go 1 more wide, that has an area of 3. So I'm actually going to set up a little table, area and perimeter. So if I want an area of 3, I have a perimeter, 3 on top, 3 on bottom, 1 on the left, 1 on the right. I really have a perimeter of 8. But I could also do a perimeter of 8, 2 here, 2 here, 2 there, and 2 there. Well, now what's my area? 4. But is my perimeter still 8?
No.
Yeah.
Yes.
Is this still a rectangle?
Oh, yeah.
Yeah, squares are rectangles. Rectangles are not always squares, but squares are always rectangles. So I just drew 2 different shapes with the same perimeter, but different areas. Now what if I make my perimeter bigger than 8? So let's draw a perimeter. So I'm going to do... Huh? Yeah, I mean, you're going to run out of space probably, but if you make your graph really nice, like if I'll change colors, I'll come up here. I'm going to go 2 tall and now 3 wide. So now I've doubled the area from my blue rectangle on top to my green rectangle. Now my area is 6 because it's got 6 boxes, but what's my perimeter? Yeah, 10. I could do another shape with a perimeter of 10. Well, that'd be kind of hard. Let's get a bigger perimeter, but can I get a smaller area? Can I get a bigger perimeter with a smaller area? So what if I go, I may run into my other shapes. What's the perimeter of my red rectangle there? Perimeter. I've got 5 on the right side, 5 on the left side, 1 on top, 1 on bottom. My perimeter is now 12, but what's my area? 5. So does a bigger perimeter always mean a bigger area when dealing with rectangles?
No.
My perimeter got bigger, yet my area got smaller. My perimeter got bigger, yet my area got smaller. So that's the weird thing about rectangles. Because the shape is not always consistent, I might be a skinny rectangle, I might be a fat rectangle. That perimeter versus area, there's no direct relationship. My perimeter can get bigger and my area can get smaller. Now what about with circles? If we start out with a really easy circle, we're going to go a radius of 1. So draw a circle right up here in the top corner. Do the best circle that you can. It's going to end up kind of looking like a Pokeball. So we know that my circumference is pi times the diameter, right? So my diameter here would actually be 2. So this circumference would be 2 pi, right? And the area of it, well, it's pi r squared. What's my radius? What's my radius here? If my diameter was 2, my radius is 1, right? So my area is actually pi, whatever my units are, squared. So wait a minute. My circumference was 2 pi, but now my area is just pi. How's my area less than my circumference? We did a got it question about this yesterday, relating area and circumference. Thomas?
I think this, but I don't know if this is true. Because the radius is smaller than the diameter, it will be. And also the radius is 1.
Yeah, we know all that. Here's the big difference. Circumference would be in units, where my area is in units squared. Remember that we cannot directly relate these two things because they're in different units. Now, so there the area, quote unquote, smaller, numerically was smaller. Let's try a bigger circle. Let's do a circle with radius of 2. So you want to be 2 down from the top and 2 over from this side. So if I draw my circle, not a very good circle. So now my circumference, well, again, is pi times the diameter. My diameter is 4, so it's 4 pi. But my area is pi r squared. Well, wait, my radius here is 2. 2 squared is 4, and my area becomes 4 pi. So now my area and my circumference are quote-unquote the same, but they're not because they're units. We'd have units versus units squared. But numerically, they're the same. What do you think will happen if I draw a circle with radius of 3? Which will be bigger, the area or the circumference?
The area.
The area, then why?
Because 3 squared is 9.
Ah, 3 squared is 9. So this is going to overlap. But if you can draw a circle with radius of 3, you want to be 3 in, 3 away. Again, this is why I suggest using colored pencils. So now my circumference, pi times diameter. Well, my diameter's 6, so this would be 6 pi. But my area, like Thomas already said, the radius is 3, and 3 squared is 9, so this becomes 9 pi. So now what we actually see is there a direct relationship between circumference and area? As my circumference gets bigger, will my area get bigger? As I make my circumference bigger. Have I showed you guys GeoGebra? GeoGebra is a really cool program that you can get on all the Chromebooks. It's a web app that, actually I'll show you how to get to it from Chrome. So if you're in Chrome and you search GeoGebra, G-E-O-G-A, it normally pops up. GeoGebra, most people are like have an issue pronouncing it, but it's G-E-O-G-E-B-R-A. It's an app, so if you go to the Chrome web store, you don't have to download anything, you can just launch it. Forget where I want to go. Maybe there. Oh, there we go. So geogebra.org/Chrome app. Now I can create my own anything in here. So I can create my own circle with a center through a point, and then I can tell it, okay, give me the distance from here to here. So there's my circumference. Then I can tell it, I want to know the area of this circle. So then, let's watch what happens as I make my circle bigger or smaller. Compare how the area and the circumference change. What happens as the circumference gets smaller? The area gets smaller. What happens as my circumference gets bigger? So is there a direct relationship there? Yeah. Unlike a rectangle, which I can draw in multiple ways, I can draw these rectangles different thicknesses, different ways. A circle, there's no different ways to draw it. It has to be perfectly circular. So as the distance around the circle increases, the area inside of that circle is going to increase because it just has to. You can't make the distance around it longer without making the space inside of it bigger. An ellipse is not a circle. So that's where the rules kind of get broken. But still, if you have an ellipse that is similar to a previous ellipse and you have a larger distance around the ellipse, it'll have a larger area as long as it's similar. But not all rectangles are similar. That's where the issue comes into play. All right, so let's actually dive in and do some problems. At least when this was made, this was true. The world's largest coin is a giant gold coin in Canada, has a circumference of 61.9 inches. Guys, what else is about 61 inches tall? Or like 61 inches?
Us.
Almost 62. Yeah, you. 5 feet. Who in here is 5 feet? Like just over 5 foot? Not like 5'6" or something, but like just about 5 foot.
I'm just 8 foot.
So, Luke, stand up real quick. If we took Luke's height and curled it down into a circle, made that the circumference, that would be a gold coin that big. Guys, we're talking a gold coin like this big. My arm span, your arm span is supposed to be the same as your height. Middle finger to middle finger, arm span is the same as your height. So, Luke, do this for us. Make it like a basket almost. That's how big the gold coin is. That's how big the gold coin in Canada is. But what we want to figure out is what is the area of this gold coin. So I'm going to pop over your notes because I don't need to play that. So we've got a giant gold coin. We've got a circumference of 61.9. Now, if we're trying to find the area, let's start by writing down our area formula. Area equals pi times radius squared. You know what that tells me is I need the radius in order to find my area. Now, why is that kind of a pain here?
All we have is the circumference.
All we have is circumference.
But isn't that I don't know how to find it. But isn't that diameter?
Isn't that the diameter? Diameter is distance across. Circumference is distance around. So, Bunger, what do you think we could do here?
You divide 61.9 by pi to make, or well, 3.14.
So I can set up my circumference formula. I can say crust equals pi dough. I know my circumference is 61.9. So exactly what Ethan said was to get my diameter by itself, all I have to do is divide by pi. Please make sure you're writing this down with me. So if we divide by pi over here, and it tells me to use 3.14 for pi, So when I do it over here, I'm going to replace it with 3.14. That will give me my diameter
Is 19.7.
19.7. But Ethan, that's the diameter. I need the radius.
Divided by 2.
So then to get the radius, we just chop this in half and we find out that the radius is,
9.85.
thank you, 9.85. And we know that we are working in inches here, so I'm going to go ahead and label my radius as inches. So now that I know my radius, I come back to my area formula and say, oh, well, area, you will be pi. Well, I'm going to replace my pi with 3.14 times the radius squared, 9.85 squared. Do not think that you can use your diameter for the r squared. Remember, your diameter is 2 times r, very different than r squared. So when you're doing this, leave the 9.85 in your calculator, like once you did this division, then just hit the square button and it will grab that number, square it, then hit times 3.14.
And that equals 304.9.
304.9. What's my label?
Squared.
Inches squared. Any questions on the process that we just did? We took the circumference, worked backwards to find the diameter, chopped it in half to find the radius, squared that and multiplied by pi to get my area. So this is really kind of a two-step problem. You got to start by finding the radius, then plug it in, find the area. Are we good, or did we have a numerical? It was 0.6. 304.6.
Because you did the pi symbol.
Ah, you cannot use the pi symbol. So correct that if you want. It's not a big difference. But on digits, it'll make a big difference. On my mastery, you can use 3.14 or the exact pi symbol. I know the range of the answers that I'm looking for. So I'm not going to like dock if your 10th place is off. I'll know if you did the process right. Try the got it on your own. I will mosey around the classroom, and if you are having any issues, please stick up a hand so I can help you. They start by giving you circumference. They tell you to use 3.14 for pi. Actually, I'm going to move this down so I see it's above and below. So when all the work is in your calculator, when you go back to check it, like when you go back to do it on digits, if you forget like, oh wait, what did we do again? You have no process written down here. So try to get some process written down. Guys, I know we're doing the computations in our calculator, but you need to write down the process. Question or answer? Question? So it says approximate because we're using 3.14 instead of exact pi. So this is your diameter. We then take that and find the radius. Yeah, you don't have to write all that down. You could just write down 7 point like squiggly to know that there work, but then keep working in your calculator.
Okay. I think I got it. No, I know.
I got it. Jeez, dude, I'm calling either of you guys.
Oh, sorry.
Just because you're like fighting each other. No, I'm just gonna use cards.
Just go until you see one of our names first.
That would not be the purpose of using cards. That would be like the opposite.
But it's like,
I'll
you
put
don't know
Divine's
whose name
cards
will be
first.
first.
Because they switched classes, or we had to like move some people around. All right, Isaiah. Can you tell me what you did first?
Divide the circumference by pi.
Mm-hmm. So we set up crust equals pi dough. Then we say, well, to get the diameter by itself, we're going to divide by pi. And we got that our diameter was approximately 7 point and then some stuff. You want to leave that there while you're working with it. And in your calculator, then just chop it in half to get that the radius was
3.5 squared. And then you have to square it.
3.503, so it depends on how exact we want to be. But again, this 3 in the thousandths place is not going to change your value that much. So actually, did you keep the 03?
Yeah.
Did somebody over here drop the 03?
I did.
You just used 3.5, so I'm curious how different the answers would be because it won't be very far. So we square that. I'm going to plug it into my area formula because that's the best way to not make mistakes. Square it and then multiply by pi or 3.14. So, Bunger, what'd you get if you kept the
38.53.
That's what I got.
0.53?
Or just 5.
And when you dropped this,
I got
exactly.
38.465.
Mm. So yours is lower by 65 thousandths.
But we're close.
Yeah, you're totally close enough. So that's why we're saying approximate. With the number 22 to start, it makes it not very nice. But either of these would be totally fine. But both of these answers would be wrong right now.
Come on, because we didn't do an exact.
No.
You just have to do 38 because it rounds.
Crystal? You need a unit! Otherwise, I'm going to write on your paper, dogs, cats, pizzas, question mark.
CM squared.
I wrote squared. Shouldn't it just be like rounded down since it's approximate?
Yeah, so we could round to about 38.5. Yeah, I would have, either of these would have rounded to 38.5, so that's what we would have rounded to.
Digits, if we're not exact, we'll get it wrong.
No, not well. On digits, it'll tell you where to round to, but on my test, you can be as accurate as you want. I like things out to the hundredths place, just because money, financial, it's nice to work with hundredths place decimals. Next week sometime. Yeah, tomorrow we're gonna have a short class, so we're just gonna have class. I don't really need it. You guys have been killing it. Maybe I'll think about it. All right, we can work through this table pretty quickly because we know the radius, and the radius tells me pretty much everything I need to know. Because if I'm going to put my area in terms of pi, we're going to leave all these in terms of pi. All I have to do is square my radius and then put a pi on the end of it. So Divine, if my, where is Divine's not here?
Went to the bathroom.
Katie, hey, there's Divine. You're back. Yeah. Divine, if my radius is 6, what's my area in terms of pi? So remember, area is just pi 36. 36 pi, and then it'd be centimeters squared, but my label is already up here. So we're just going to work straight down the area column. Katie, if my radius is 8, what's my area? What's 8 squared? Yeah, 64 pi. Cassidy, you're not here. We miss you. Zach, what about 10? 100 pi. 10 is easy to square. All right, now let's work through the circumferences. So remember, circumference is just pi times the diameter, but if we're given the radius, we double it and then put pi on. So Layla, what's my circumference when my radius is 6? 12 pi. Thomas, what about my circumference when it's 8?
The circumference when it's 8 is 16 pi.
16 pi, exactly. Luke? 20 pi. Now, if I look at the area divided by the circumference, we're just going to set up these ratios. So in this third column, just set your ratios of area over your circumference. prize question. I don't know a better name to call it. You'll get a piece of candy. If anybody can tell me the relationship that those ratios really show me.
Wait.
You really have to do the fourth column first. Wait.
They have like multiple so you can simplify it.
Yeah.
Like, it's like going down by 3 or but then 5. You could just
But what relationship is that actually showing me? Thomas?
It's like +1 area every time.
But why? But what relationship is there? Why did we make a table of this?
Because I don't know.
Ethan?
To show how the circumference relates to the area. The area related to the circumference.
Jeez, bro.
So that you don't choke, Brennan.
Yeah. I don't know if I can with it, but so the simplest form, 36 divided by 12 is 3. Yeah, that's what.
Yeah, 3 to 1 or 3.
3, 4, 5. The next one's 4.
Oh crap.
This one's 5. Yeah, and the next one's 5.
Come back, smart board.
That's
But what relationship is that actually showing?
There's a pattern.
It's I had it.
The area divided by the circumference will always be, that ratio will always be, Eli? No. It's changing. It's 2, then it's 3, then it's 4, then it's 5. Mariana?
It's half of the radius.
It's half of the radius. If the radius is 4, that ratio is 2. If the radius is 6, that ratio is 3. If the radius is 8, that ratio is 4. If the radius is 10, that ratio is 5. So guys, your area divided by your circumference will always equal half the radius. See me after class. So make sure you write that down somewhere at the bottom. Then we need to predict. Use this pattern. If the radius was 32, what would the ratio of area divided by circumference give us?
Bad word.
If the radius was 32, that would give us... Oh, you don't need a calculator for this.
I know. Sorry, it was
What is it?
60.
So guys, what this tells me is a whole batch of new formulas. Check this out. If I want to isolate the area here, I can just multiply by circumference. So really, area is half of the radius times circumference. Because remember, this is really half the radius. So if you know the circumference, then you can figure out the radius. And from there, you know the area. Half the radius times the circumference is another area formula. If I was you, I would throw that down somewhere because it may eventually become useful. So, our ratio of area to circumference is given to us as 11. What does that tell me about the circle? Oriana?
Its circumference is 22 pi.
Ooh, not 20. Well, okay, you got to be really careful with how much you try to do at once. Area divided by circumference is always half the radius, which in this case is 11 to 1, or just 11. So that really tells me that the radius is 22, right? Then I can use that to figure out my circumference, because circumference is always pi d, and we want to leave our answer in terms of pi. So it's not 22 pi, it's 44 pi. Try the got it. Sorry. Not this got it. Thinking of a different got it. Oh, that's why I put extra problems on here. So, we can use our mathematical formulas to represent why this happens. Just watch for right now. Or I mean, interact with me, but don't write anything down right now. So we're going to use formulas to look at why area divided by circumference comes out to be half of pi. What's my area formula?
Area
equals pi times radius to the squared.
Pi times radius squared, which is really radius times radius, right? Circumference is pi times diameter, which is really pi times 2 times r. These pi's cancel each other out. These r's cancel each other out, and what I get left with is r divided by 2, or just half of r. And that's it. Because those formulas have such similarities, they cancel out everything except for the radius on the top divided by the 2.
Did we write that down yet?
So really, you could work with half radius or radius divided by 2, which I actually like radius divided by 2 a little bit better. Thomas, you got this written down?
I can't write
So we're going to try these final do you know how problems. Oh, geez. I'm going to give you 4 minutes. I'm going to give you a minute per problem to try to get all 4 of these done. And then we're going to come back and see who is on their A game today.
Oh, I'm ready.
So you have 4 minutes starting now. Yeah, you can get these done. A minute per problem, that's okay. I'm going to start by writing down our formulas. We could write down the formula for circumference because we know it. And we could write down the formula for area if that's what we want. So I would always keep handy, like you don't have them really explicitly written anywhere. I would keep handy off to the side somewhere or like on a post-it note or something that your area formula is pi r squared and that your circumference formula is pi times diameter, which diameter then we can just drop in half to find the radius. So from there, we could set up the circumference formula over here and plug in 38 for my c, and then just divide by pi on both sides to find the diameter, which is the same process we took over here. We plugged in the circumference divided by pi to get the diameter. We then took that value that we got, chopped it in half, and then we square it, and then multiply by pi, because that's what my area formula tells me. Take the radius, square it, and multiply by pi. So try it out. Other issues? You did 3.14, right? It looks like just 3.4. Yeah, everything looks good. Now the dangerous thing is we can't do this again, because now the answer that it pulls will be the previous answer. So we'd have to do that times 3.14 again to get that same answer we just had. You have 1 minute and 19 seconds. I will in just a moment.
I got the first one now.
I got most of them except for I got all of them except for 4C.
I got all of them except for 2, 3, and 4.
Oh wow, nice.
So you should be continuing to work, not talk.
I don't know how to solve it.
I don't
You do 4, but the circumference is 7.
All right, let's bring it back together. You have 30 seconds left, but I'm going to go ahead and bring us together so we have time to cover all of these.
I just completed it.
Bella, can you walk me through your process for number 1?
Okay, so circumference. Okay, so I did 38, which is the circumference, is equal to pi times d for diameter. And then I did 38 divided by 3.14 on each side. And I got 12.09 for the diameter. Then I divided that by 2 to give me the radius. And I got 6.04. So then I squared the radius and I got, I got 36.48, and then I multiplied that by 3.14.
And got, thank you.
And I got 114.85. And would it be yards squared?
Because my circumference was in yards, you are correct. This would be yards squared. You should have something close to that. Depending on whether you used exact pi,
114. I got like 960.
you're fine. Yeah, if you have 114, you're fine.
Okay.
You might have a little bit of a difference because rounding here, because this would have actually been like 0.45 something, I believe. So if you kept more of the decimals on, you'll have a more exact answer, but it's fine. I know the range of what I'm looking for. Be careful with what digits gives you because it will be specific with like round to the hundredths place as you work, or round, like it'll tell you what to do.
I got 160, but I think I put 4.
You maybe used exact pi too or something like that. Eli, you able to talk me through your process for number 2? Can you start me at all? So what's area divided by circumference supposed to equal, Eli? Half of the radius, right? And if that equals 7, then what does that tell me the radius actually is here? If the 7 is half the radius, we actually have to double to get to the radius. So it would actually be 14. So then, if we want the circumference, what do we do now, Eli? How do we find circumference? What's our formula? So it's not on the scene. Pi times the diameter. If my radius is 14, what's my diameter? So I think you just probably haven't done this practice yet. Yeah, right. Have you done the 11-1 practice? So it's showing right now. Like you don't know what you're doing. So you need to do your practice. No more of this hiding in class. Like when I can't see you, I think you think like you're exempt. No more of that. Okay? Do your practice. Who can help find the diameter if I know the radius? What? Not in this specific situation, but any time. How do I find the diameter if I know the radius? Abby? Yeah, to find the diameter, it's double the radius, so I times 2 and my diameter becomes 28. Once I know that, and I'm going to leave this in terms of pi, what's my circumference? 28 pi. All I have to do then is throw a pi on the end of here, and I have my circumference. I need a label, and I don't have one in the problem, so I just call it units. Bela. The ratio of the area of the circle to the circumference is 5 to 1. Find the area of the circle. So how'd you process through this? Okay, so walk through it with me then. Because what we did in the last problem, we know that area to circumference is always equal to what? Half the radius. So if here that equals 5, then what's my radius? 10. So all we have to do is double that ratio to get my radius. From there, do I use the radius to find area? Yeah, so I don't need my diameter. I've got my radius, which is what I want. This problem's easy because to find the area, it's just pi times the radius squared. Well, what's 10 squared? 100. And if I want my answer in terms of pi, this is just, no. In terms of pi, don't calculate it. Pi is pi. It's just 100 pi. And then it'd be units squared. You are going to have problems like this on your homework, so please make sure you understand how we process through these. The ratio of area of the circle to circumference is 6:1. Find the circumference and the area, so essentially combining problems 2 and 3. I'm going to give you a minute to do this because some of you guys had not done it. We just did 2 and 3 together. You should be able to do this. Using this ratio, find your circumference and find your area. All right, bring it back together. People I've talked to, people I've talked to. I think I've talked to Franny. We haven't really talked much today. Franny, can you process through what your at least initial thought process was?
Well, I just multiplied 6 times 2.
Yeah. So you got.
12.
And then to find circumference, what'd you do?
I multiplied 12 times 2.
Yeah, to find my diameter, that's 24. So what was your circumference?
My circumference was, I accidentally did the area first.
Oh, that's fine. Give me area then.
452.6.
Ooh, you calculated it. We want it in terms of pi. So you would have just undone your multiplication by 3.14 and you would have gotten 144 pi. And your circumference here should have been, anyone?
24 pi!
24 pi. Please do your practice. Come to class with questions tomorrow if you have any.